Hello friends, my name is Jay and today me and my friends Gaurav and Jamin are going to give you a brief idea about what cloud computing is, what and how cloud computing works and what are the different service models about cloud computing and the advantages and disadvantages of it. Okay, so let's start with what cloud computing actually means. Cloud computing is a style of computing which comes into focus and only when we think a way to increase capacity or add capabilities without investing anything in a new infrastructure that is like any hardware or software. It is a large network of computers used by large organizations to provide services to smaller and also other individuals. It is also used for bulk data processing. It is an emerging technology that uses the internet and central remote servers to maintain data and applications. This technology allows much more efficient computing by centralizing storage, memory, processing, and bandwidth. Next is the definition. There are many definitions for cloud computing. Here are some of them. The one defined by MIT says that the idea of relying on web based applications and storing data in the cloud of the internet. The other definition, defined by Mark Anderson, defines it as follows: the cloud is a smart, complex, powerful computing system in the sky that people can just plug into. Also, cloud computing allows consumers and business to use applications without installing and access their personal files at any computer with internet access. So next we'll look into the history about cloud computing and how it actually evolved. The concept of cloud computing was proposed back in 1960s when John McCarthy stated that computation may someday be organized as a public utility. The actual term cloud was borrowed from telephony and telecommunication companies who until 1990s used to offer dedicated point-to-point data circuits and then later began to offer VPN, that is virtual private network services. One of the first milestones of cloud computing was the arrival of Salesforce.com in 1999, which pioneered the concept of delivering enterprise applications via a simple website. The next slide discuss about other new developments and milestones achieved using client computing. They are as follows. The next it is the first is the Amazon EC2 S3, which is called as Elastic Compute Cloud and Simple Storage Solutions, which was developed in 2002, which provided a suite of cloud-based services including storage, computation, and even human intelligence through Amazon Mechanical Turk. The Amazon EC2 S3, which is called as Elastic Compute Cloud Simple Storage Solutions, was the first widely accessible cloud computing infrastructure service. It is a web service that provides resizable compute capacity in the cloud. It is designed to make web scale cloud computing easier for developers. The next development is Eucalyptus, called as Elastic Utility Computing Architecture, linking your programs to useful system, which was developed in the early 2008. It was the first open source AWS API, that is Application Program Interface, compatible platform for developing private clouds. By mid 2008, cloud computing became the platform to shape the relationship among consumers of IT services, those who use IT services and those who sell them. Another big milestone came in 2009 as Web 2.0, and then Google and others started to offer browser based enterprise applications through services such as Google Apps. The next we'll discuss about how cloud computing actually works. The figure given describes about the working of cloud computing. It shows about how an end user can be able to use the services of cloud computing. Basically, the cloud computing system can be divided into two sections. First is the backend, and second is the front end. They both are connected to each other through a computer network, which is usually the internet. The front end of cloud computing is the side of computer user or client sees. The backend is the cloud section, which is the main section of the system. On the backend, there are various computers, servers, and database storage systems, which creates the cloud of computing services. A central server administers the system, monitoring traffic and client demands to ensure everything runs smoothly. This server follows a set of rules which is called protocols and uses a special kind of software called middleware. uh, Suppose for an example we can explain how it actually works. Let's say you are an executive at a large corporation and your particular responsibilities include making sure that all the employees have the right hardware and software they need to do their jobs. Buying computers for everyone isn't enough. You also have to purchase software or software licenses to give employees the tools they require. So, whenever a new hire is done, you have to buy new software or make sure your current software license allows other users as well. This in turn would increase the cost of buying new software or software licenses. So, the solution for this can be that instead of buying and installing a suite of software for each computer, you would apply only have to load one application. That application would allow workers to log into a web-based service which hosts all the programs then the user would need for his her or her job. Remote machines owned by another company would run everything from email to word processing to complex data analysis and various other programs. In cloud computing, there is a significant workload shift. Local computers can no longer have to do all the heavy lifting when it comes to run applications. The network of computers that make up the cloud that handles them instead. The only thing the user computer needs to be able to run is the cloud computing system's interface software, which can be as simple as web browser or cloud network take care of the rest. The next is the architecture, which is a three-tier model, which which consists of three three services. First is infrastructure as service, second is platform as service, and third is software as service. Cloud services are for the lowest tier is the infrastructure as service. With IaaS, users can run software on machines owned and configured by a third party. IaaS makes up the hardware and software that supports the whole system from the server to storage and networks. The next tier is the platform as a service, which is also called as PaaS. PaaS is basically a platform that supports the complete life cycle of building and delivering applications and services over the web. PaaS provides services to deploy, test, host, and maintain applications within the same integrated development environment. With PaaS, each platform component, whether middleware, messaging, integration, or communication, is provided as a service. The, the most visible layer to end users is the last one, which is software as a service, which rests on top of the PaaS layer. With SaaS, users can access pre-baked services simply by navigating to them via web browser or without bothering with hardware and software details involved in implementation. This is what the architecture of cloud computing consists of. The next is the deployment models, which would be explained by my friend Gaurav. Thank you.
Thank you, Jay. I am Gaurav Sekharia. Now I will continue this presentation. So let's start with cloud deployment model. There are four deployment models, namely first public cloud, second communication cloud, third private cloud. Fourth, hybrid cloud. Okay, now let's get some brief idea about those models. First of all, public cloud. A public cloud infrastructure is available to the general public and it is provided by the third party, that is, cloud service provider, in short CSP. In a public cloud, an agency dynamically provisions computing resources over the internet from a CSP who shares its resources with other organizations. Similar to an electric utility billing system, CSP bills the agency for its share of resources. This model can be most cost effective for agencies because it gives them the flexibility to produce only computing resources they need. But one thing is that an agency must accept that reduced control and monitoring over the CSP's governance and security. Now, second one is community cloud. A community cloud infrastructure is produced jointly by several agencies on the program that share specific needs such as security and compliances. The agencies or CSP, that is cloud service provider, may manage the communication to cloud and may keep it on premise or off premise. When organization or agencies have a common set of requests and customers, a common cloud enables them to combine asset and share computing resources, data and capabilities. By eliminating duplication of similar systems, agencies can save money as well as allocate their resources more efficiently. Now third one is private cloud. A private cloud infrastructure is operated solely by a single organization or any agency. Cloud service provider dedicates specific cloud service to that agency and no other customers or clients. The agency specifies architectures and controls a pool of computing resources. A common reason for agency to accept private cloud is their ability to enforce their own data security standards and controls. An agency will typically host a private cloud on premises, connect it through provide private link and only share its resources within the agencies. Because resources are not pooled across multiple unaffiliated organization, an agency will pay for all of cloud's capacity. Now third, the last one is hybrid cloud. There is data security issue with public cloud as well as with private cloud. The resources are limited in public cloud as well as in private cloud. So the solution is a hybrid cloud in which combines both public or private cloud model, which is a mix of both internally and externally hosted services. Agencies will likely not limit themselves to one cloud deployment but will rather incorporate with different and overlapping cloud services to meet their unique requirement and other requirements. Hybrid deployment models are complex and require careful planning to execute and manage. Example of cloud services. Now let's see some examples of cloud services. There are many applications of cloud computing. Different provider provides different applications. A cloud service includes products, service, and solutions that are delivered and consumed in real time over the internet. Some applications that are provided by different applications like integration application is provided by Amazon simple queue service, search engine application provided by Google custom search application like video game is provided by online on live chat is provided by live person and payment provided by most famous site PayPal. Okay, these are the companies that provide cloud computing. But there are big names like Google, Amazon, eBay, Facebook, and IBM. Google has all applications in these all applications in which they provide cloud storage and manage data in cloud computing. Applications of Google like Gmail, YouTube, Google Maps, Picasa for photos, and Google Blogger. Now, eBay is also one of the company that uses cloud computing, and they manage the data for shopping, merchandise, trading, merchant services, and research services. Okay, Facebook is also a company that uses cloud computing for storing photos, events, and friend list and pages for different organization and profiles for different users. Okay, now these are all companies that provide cloud computing to other for other companies like Google and IBM are most famous companies. Google provides a storage that allows you to create anything from simple website to complex applications. Snapchat and Rovio are customers of Google Cloud Computing. Okay, now my friend Jamin Patel will explain rest of presentation. Thank you.
Thank you, Guru. Now, myself, Jamin Patel, going to discuss further. Let's start with key features. First of all, agility. Agility improves with users' ability to reprovision technological infrastructure resources. Application Programming Interface (API) accessibility to software that enables machines to interact with cloud softwares in the same way in like the traditional user interface, like a desktop computer, facilitates interaction between humans and computers. Cloud computing systems typically use representational state transfer based APIs. Now cost. It, redu- it reductions claimed by cloud providers. A public cloud delivery model converts capital expenditure to operational expenditure. This properly lowers barriers to entry, as infrastructure is typically provided by third party and does not to be purchased for one-time or infrastructure incentive computer tasks. The eFiscal project's state-of-the-art repository contains several articles looking into cost aspects more detail, most of them concluding that cost savings depend on the type of activities supported and the type of infrastructure available in-house. Now, devices and location independence. It enables users to access the system using web browser regardless of their location or what devices they use like personal computer, mobile phones, tablets, etc. It does not care if a user is in the United States or India or Russia, wherever. Next, multi-tenancy. It enables sharing of resources and costs across a large pool of users. Thus, it allows for centralization of infrastructure. Peak load capacity increases and utilization of efficiency improvements. Reliability. Reliability makes cloud computing suitable for business continuing and disaster recovery. And security. Security can improved due to centralization of data, but concerns can persist about loss of control over certain sensitive data and the lack of security for stored kernels. Security is often as good as or better than other traditional systems. Private clouds installations are the part motivated by users' desire to certain control over infrastructure and avoid losing control of information security. Now maintenance. Maintenance of cloud computing applications is easier as they do not need to be installed on each user's computer. It is quite good. Now we come to the essential characteristics of cloud computing. The National Institute of Standards and Technology defined cloud computing identifies five essential characteristics as follows. First of all, on-demand self-service. A consumer can unilaterally provision computing capabilities such as server time and network storage as needed automatically without requiring human interaction with each service provider. Then broad network access. Capabilities are available over the network and accessed through standard machines that promote use by heterogeneous this or thin thin client platforms like mobile phones and tablets and laptops, etc. Resource pool. The provider's computing resources are pooled into several multiple consumers using a multi-tenant model. Then rapid elasticity. Capabilities can be elastically provided and released to scale rapidly outwards and inwards communicates with demand. At last, measured service. Resource uses can be monitored, controlled, and reported, providing transparency for both providers and consumer of the utilized service. Now we come to merits and demerits of cloud computing. Let's start with advantages. There are lots of advantages. First of all, reduce runtime and response time. Cloud computing makes applications straightforward. To use 1000 servers to accomplish a task in one or 1000 at the time a single server would require. Uh, Minimizes the infrastructure risks, then lower cost of entry because infrastructure is rented, not purchased. Increase the pace of innovation. The low cost of entry to new markets helps to level playing field, allowing startup companies to deploy new products quickly and at a low cost. Then it, it has some business benefits. Cloud computing is environmental friendly, ease of backup when compared to backing up all thick client PCs, disaster recovery, scalability, and mobile mobility of transformation as it can be used globally. Let's discuss some disadvantages. First of all, regulatory compliances. Then it is only possible to use applications or services that are provided is willing to offer the required internet connection. United States and Europe have different privacy standards, arises conflict. Recovery in cloud computing is more difficult. Next, uh, cloud computing does not allow user to physically store their data, so data storage is concerned. Often limited or no technical support available, so when there are technical issues, you may lose access to your data or your application. Conclusion. At the last, it is concluded that cloud computing brings significant promise in terms of scalability, reliability, competitive advantages, cost reductions, and simplified maintenance across the enterprise, along with high ability and automation. Cloud computing provides supercomputer power. This cloud of computer extends beyond a single company or enterprise. Although cloud computing enables products, service, and solutions, today all small businesses do not have capabilities of building an infrastructure that will support cloud computing. That is the major disadvantages. thank you guys for watching us. Thank you so much.